This video will cover beginner part 3 questions relating to the topic of curve sketching. Number 1. The domain is the denominator cannot be 0. That means x squared cannot be 9. X cannot be plus minus 3. The x-intercept is when y equals 0, that means the numerator is 0. Then we can factor x equals minus 1 and 1. Then x-intercept are minus 1, 0 and 1, 0. Y-intercept is when x equals 0, then y of 0 equals 0 minus 1 over 0 minus 9, which is 1 over 9. Then y-intercept is 0, 1 over 9. F of minus x equals minus x squared minus 1 over minus x squared minus 9 equals x squared minus 1 over x squared minus 9 is the same as f of x. Since f of minus x equals f of x, that means the function is even. So the curve is symmetric about the y-axis. Limit as x approaches infinity of x squared minus 1 over x squared minus 9. When you put infinity into x, you get infinity over infinity form. The highest power of x in the denominator is x squared. So divide by x squared or times 1 over x squared on each side equals limit as x approaches infinity, then expand x squared over x squared minus 1 over x squared over this one, x squared over x squared minus 9 over x squared. Then we can rewrite as x approaches infinity, this is 1 minus 1 over x squared over, this is 1 minus 9 over x squared. Then plug infinity into x, 1 minus 1 over infinity squared, which is infinity, over 1 minus 9 over infinity squared is also infinity. That means 1 minus 0 over 1 minus 0, 1 over 1, which is 1. Or there is a shortcut. When you see the question in infinity over infinity form, just to take the highest powers of x in the numerator and the denominator, which is x squared over x squared. The answer is 1, is the same. If you can understand this part, click on the video in the top right for more. Limit as x approaches minus infinity, x squared minus 1 over x squared minus 9 is the same technique, is infinity over infinity form. Then use the shortcut, then x squared over x squared, which is 1. Now with these two limits, we have horizontal asymptote is y equals 1. Limit as x approaches minus 3 from the right side, x squared minus 1 over x squared minus 9 equals minus 3 squared minus 1 over the number line 0 and minus 3. Minus 3 from the right side is here. Then minus 3 from the right side square is less than 9. Just think of it as 8.99999. So 8.99999 minus 9 equals 9 minus 1 over 0 from the left side equals 8 over 0 from the left side. That means just a little bit less than 0. And this part is only in our head. The answer is 8 over 0 means infinity but negative. When you plug in the number from the left or right side, don't worry about the numerator. The important part is the number over 0 makes infinity. We have to find positive infinity or negative infinity. Limit as x approaches minus 3 from the left side, x squared minus 1 over x squared minus 9 equals minus 3 squared minus 1 over minus 3 from the left side is here. This one is just a little bit less than minus 3. Then minus 3 from the left side square means 9.00001. So 9.00001 minus 9 equals 9 minus 1 over 0 from the right side. That means just a little bit greater than 0. So 8 over 0 from the right side. And this part is only in our head. Then 8 over 0 makes infinity and positive. Then limit as x approaches 3 from the right side, x squared minus 1 over x squared minus 9 equals 3 squared minus 1 over this one. 3 from the right side is here. This one is just a little bit greater than 3. Then 3 from the right side squares means 9.00001. Then 9.00001 minus 9 equals 9 minus 1 over 0 from the right side, which means 8 over 0 from the right side is just a little bit greater than 0. Then this part is only in our head. Then 8 over 0 makes infinity and positive. Limit as x approaches 3 from the left side, x squared minus 1 over x squared minus 9 equals 3 squared minus 1 over 3 from the left side squares means just a little bit less than 3. Then this square means 8.99999. Then 8.99999 minus 9 equals 9 minus 1 over 0 from the left side, which means just a little bit less than 0. Then 8 over 0 from the left side. This part is only in our head. 8 over 0 makes infinity but negative. With this, vertical asymptotes are x equals minus 3 and x equals 3. Let y equals f of x. F prime of x equals, use the quotient rule, u over v prime equals u prime v minus u v prime over v squared. Then x squared minus 1 prime times x squared minus 9 minus x squared minus 1 times x squared minus 9 prime over x squared minus 9 squared equals, first one is 2x times x squared minus 9 minus x squared minus 1 times 2x over x squared minus 9 squared. Then expand 2x cubed minus 18x minus 2x cubed minus 2x, then minus again, then make 2x over x squared minus 9 squared equals 2x cubed is cancelled, then minus 16x over x squared minus 9 squared. Then f prime of x equals 0. That means the numerator is 0, which is 16x equals 0. Then x equals 0. F prime of x does not exist. That means the denominator x squared minus 9 squared equals 0. That means x squared minus 9 equals 0. X squared equals 9. Then x is plus minus 3. But we cannot use this because the domain cannot be plus minus 3. So the only critical number is x equals 0. There's number line f prime of x minus 3, 0, and 3. This is a broken line because x cannot be plus minus 3. When the testing number is x equals minus 4, the denominator is always positive, so we can check about only the numerator part, which is minus 16x, 64, which is positive. When the testing number is x equals minus 1, then minus 16 times minus 1 is 16, which is positive. When the testing number is 1, x equals 1, minus 16 times 1, minus 16, which is negative. When the testing number is 4, minus 16 times 4 is minus 64, which is negative. F prime changes the sign from positive to negative at x equals 0. So relative maximum at x equals 0. Then f of 0 equals, use this one, 0 squared minus 1 over 0 squared minus 9 equals 1 over 9. Then the relative maximum is 0, 1 over 9. F second prime of x equals, use the quotient rule, minus 16x prime times x squared minus 9 squared minus 16x times x squared minus 9 squared prime over x squared minus 9 squared then squared equals minus 16x prime is minus 16 times x squared minus 9 squared minus, make positive, then plus 16x, then times, use the chain rule, prime outside first, then 2 times x squared minus 9 times x squared minus 9 prime over x squared minus 9 to the power of 4 equals minus 16 x squared minus 9 squared plus this part together 32x times x squared minus 9 times this part is 2x over x squared minus 9 to the power of 4. Then divide by x squared minus 9 on each side. So cancelled. This is only 1 left over. This is 3. Then minus 16 x squared minus 9 plus 32x times 2x over x squared minus 9 to the power of 3. Then expand. Minus 16x squared plus 144 plus 64x squared over x squared minus 9 cubed equals, this part together make 48 x squared plus 144 over x squared minus 9 cubed. F second prime of x cannot be 0. That means there is no inflection point. There's number line f second prime of x, then minus 3 and 3 is a broken line because the domain cannot be plus minus 3. Now the numerator is always positive. We only check about the denominator, which is x squared minus 9 cubed. When the testing number is minus 4, then minus 4 squared minus 9 cubed means 16 minus 9 cubed, which is positive, concave up. When the testing number is 0, then 0 minus 9 cubed means minus 9 cubed, which is negative, concave down. When the testing number is 4, then 4 squared minus 9 cubed means 16 minus 9 cubed, which is positive, concave up. Now we know x cannot be minus 3 and 3. So this is undefined, undefined, undefined. This is the same, undefined. Then f prime of x equals 0. When x equals 0, this part is 0. Then f prime of x is positive here, and then positive, negative, then negative. F second prime of x is positive. Between here is negative, then positive. F prime of x is positive. That means increasing. Positive means increasing. Negative means decreasing. Negative means decreasing. F second prime of x is positive. That means concave up. Negative is concave down. Negative is concave down. Positive is concave up. Concave up and increasing only at this part, like this. Concave down and increasing only at this part. Concave down and decreasing only at this part. Concave up and decreasing only at this part. And x equals minus 3 and 3. There is vertical asymptote. When x equals 0, this one is a relative maximum. 0,1 over 9. The vertical asymptote is x equals minus 3 and 3. Horizontal asymptote is y equals 1. When x is less than minus 3, concave up and increasing. When x equal between minus 3 and 0, increasing and concave down, and passes through 0,1/9, like this, decreasing and concave down, then decreasing and concave up. X-intercept is 1 and minus 1. Y-intercept is 1/9. Then this is the graph of y equals x squared minus 1 over x squared minus 9. I hope this video has been helpful. If you have any questions, leave them in a comment below. Thank you for watching. Please like and subscribe for more.